actually very generic. It could mean a lot of other things, that if some service requires another service, that we start the service right the moment we actually need it. It's an interesting feature because you do less work, but it's not the core feature. It keeps tracks of processes using Linux C groups. Processes probably, I hope that everybody knows what a process on Linux is, but what does this mean keeps track of it using Linux C groups? Linux C groups is a new kernel interface that has been introduced, I don't know, 10 versions ago. C groups is short for control groups. What that really precisely means, I have a couple of slides about this later, but this is actually very, very useful to not only start and stop services, but also keep precise track about every process that a service spawns, and that can be quite a lot. For example, if Apache starts up, it can start a gazillion of CGI scripts and whatnot. And yeah, we use Linux C groups to keep track of them. It's about why Debian should or should not adopt systemd as a default. Of course, it's not really our decision, and we are, after all, Fedora guys ourselves. But of course, we are always interested in healthy community and cooperating with everybody else. So yeah, the first part of the talk is going to be about the why, and the second part about the talk is going to be about the why not. And yeah, we have a lot of ground to cover, but still, if you guys have any questions, I would really prefer if we could make this interactive and you ask them right away. In the worst case, I might just say, let's discuss that particular thing later, but hopefully we can make this more interactive than just me talking and you guys listening. So, yeah, let's get started with the why. Oh, by the way, I know I tend to speak quite slow. If it's too quite fast. If it's too fast for anybody, just tell me, and I'll try to be slower. Okay, so the why. Let's first start with a little bit about the superficialities of the project. It is a very healthy open source project, we believe. It has a very large community. If you look at the statistics, we have 641 mailing list members, 424 Git contributors. Of those, 241 were already from UDEF. Of course, you cannot just, if you're just interested in the ones that are only committed to systemd, you cannot just subtract the 241 from the 424, because there are quite a few who contributed to both. We have 17 different Git committers from a couple of different companies. We have 253 committers or 30 contributors per month. Of course, the 17 Git committers, there's no denying most of the stuff that's done is done by me and by Kai and by speaking. The real open source project, we are LGPL 2 plus. Basically, we don't want to have anything to do with politics, so we choose something that everybody can agree on, and that is, while still copyleft, the most liberal form of copyleft. It's inherently cross distribution. We have, of course, a lot of people from Fedora working on it, but the Arch Linux people have adopted it, so it has a lot of support for that. There's some patches coming from the Debian people, from the SUSE people who have adopted it as well. Everybody is on board and tries to pull into one direction. And of course, as mentioned, there are multiple vendors, you have Red Hat behind it, SUSE behind it, you have Intel behind it, you have quite a few other companies, you have a lot of embedded companies, you have the car companies. There's a lot of commercial power behind it. And everybody's welcome. And we mean that, right? We will, if you send us a patch, we will consider it. In the worst case, you will get an explanation why not, but usually we'll try to accommodate for your needs. And we use Git, actually, for our community stuff, so we try to be like how an open source project should be, just the thing that you can contribute to without thinking, because everybody knows Git anyway. Yeah, we do like community a lot. We have multiple hackfests per year, and we try to get everybody to attend. That sometimes even includes that we sponsor people to come to our hackfest, like the last one we actually had last week in Brno. We even got, in the previous one, we got a couple of people from Arch Linux attending. Actually, this one as well. And so, yeah, we truly want to be a healthy project there. And the hackfests are awesome. A lot of really constructive stuff always comes out of them. Yeah, of course, we participate in numerous conferences over the year. We attend all the conferences and try to make sure that everybody understands where we are going and can make themselves heard to drive it into the direction that they want. We make sure that we always are present at the developer conferences that matter, I don't know, Plumbers Conference, like this one, so that people can talk to us and we can talk to them. And we kind of kind of figure out what people actually want from this stuff. Our focus is service desktop cloud embedded, like Linux itself, basically. Right? We don't focus on one specific part, and we're strong on those. Of course, as you might know, RHEL 7 is going to ship systemd. RHEL 7 is like most famous for being a server operating system. It's relevant for the desktop. As you know, GNOME and these things like that use a lot of systemd functionality simply because we provide a lot of functionality that others don't really do. Cloud the same, embedded. It's actually very popular in embedded. Like there are companies who build it into wind turbines, and of course the car companies who build it into cars, and it's built into toys, and it's built into telescopes that look into the sky, and all of that already now. There's a question over there. Yes, I'll try. I'll probably forget it in 5 minutes, but then tell me again. Yeah, it is more than 3 years of development. We started it even a little bit over 3 years ago. Nowadays, it's used in production. As soon, and we're currently working on including it in RHEL 7. So you'll probably see it on all your servers very soon too. So much about the superficial stuff, right? About the community things and how we do things and how we, Let's now focus a little bit more on the technical things. So one thing that is actually, I think, one of the most important things, it's we believe that systemd is technically the right thing, the right design. Of course, it will have bugs like any software will, but at least fundamentally our design is right. Of course, you can only say that this design is right if you look at the other designs before. Like there's, of course, System 5 init, which I believe, and most people probably believe at this point, is systematically flawed because it doesn't react to the actual things that happen on the system. Right? It assumes that hardware is mostly static, that devices like hard disks show up at a very specific point in time and then are there and never change. And the ordering is very simplistic, I guess. With systemd, all of that is not true. We actually can listen to devices showing up, and when we boot up the machine, we will actually wait for devices to show up, run the file system checks on them, and mount them and things like that. So systemd is this dynamic thing that can adjust to what's actually happening on the system, because systems work very different nowadays than they worked 30 years ago, because everything's dynamic and you add this and that and everything like that. Of course, if you compare it to the other contender, which is Upstart, we believe that, the reason we initially created systemd actually is because we believe that the Upstart design was wrong. A little bit about the history there. We started, I played around with a little project I called BabyKit. It was back at the time where everything had to be a kit. This BabyKit thing was supposed to be like an experiment how we think that it should work. And then Upstart came along, and then I put that aside because we actually believed that Upstart would be the big and great future. However, over a year or so, and after seeing Scott a couple of times at the Plumbers Conf, we've eventually figured out that Scott's probably not giving us what we want, and we believe that inherently it had the wrong design. The reason what exactly is broken there is basically what Upstart does is you have a language how you can express how events happen and what's supposed to be done that way. What systemd does instead is you express relations between things. Now, one is a lot more flexible and powerful than the other, because in one thing you basically have the administrator figure out what should happen, or the developer what should happen in which case. You write that down, and then Upstart will just execute it. However, in the systemd design where you have the dependency tree, basically you just say these are the dependencies, and then the system will figure out what to do at what place. This has a couple of effects. Like, for example, in systemd, if you want to have a minimal boot, you want to just start that and that and that, it's a relatively easy thing to do, because you simply look at the dependency graph, figure out what you want, pull in all the dependencies, and run it in the right order. This, of course, is systematically more difficult with Upstart, because the after rules in the first place have to express what actually happens on the system. This eventually becomes even more problematic. Like, for example, something very recent is the rearrangement of C groups. I'm not sure if you guys have followed that. C groups are this thing how you can attach a label to a set of processes, and most container managers nowadays follow how containers can pass the UUID into it, and a couple of other things, like how they have to set up the environment for a systemd system so that everything just works. Because traditionally, if you ran something inside of a container, you had to change the operating system first. Like we had to remove a couple of things from fstab and this kind of stuff, and remove a couple of init scripts. With systemd, it is our absolute intention that things just work, right? So that we carefully made sure that on Fedora at least, we can boot the same image on a bare metal, or in a KVM, and in a container, and it will just work and always boot up cleanly. And there's integration with initRDs, which is something that we did for Drakit. So yeah, you can run systemd inside of the initRD, which is incredibly useful. It's one of the results, actually. Harald is going to do a talk tomorrow about Drakit and about this specific stuff. But it actually has this nice effect that nowadays Drakit is faster in transitioning to the host OS. Like it shortens the overall boot time over the kernel doing it without initRD at all, right? Which is an amazing result. And it allows init systems to even do without shell scripts in the common cases, which is, yeah, it's how things become fast. There's integration with EFI bootloaders and things like that to pass performance data around. So actually systemd, I already mentioned that, has all these profiling tools built in. So after boot up, you can actually type systemd analyze and will tell you, okay, your boot up was slow because so much time was spent in the BIOS initialization, so much time in the bootloader, so much time in the kernel initialization, so much time in the initRD, and so much time in systemd of the host. So yeah, it's nicely integrated. Of course, all of this is the kind of optional, loose integration. So there are no requirements made or anything like that, and systemd will boot in any case anyway. We have integration with security frameworks. IMA, SLInux, Mac, everything that people want to use. They just work, right? And they're written in a way that all the security transitions happen at the earliest, like policy loading, things like that, happen at the earliest possible point, so that every user space code that runs will only run with the policy applied. We have comprehensive documentation, like we have a huge body of man tell you 10 reasons why it is Unix. Like for example, I don't know, Unix means this thing that everything's a file in the file system. Systemd is that much more because we actually turn all the services into actual file, like they have representations in the file system and the C groups stuff. And there's a lot of other things. Like for example, the multi-seed stuff is something, a truly Unix idea. It was built into the terminals that have been invented like 30 years ago. They kind of fell to the wayside. People only used them for debugging servers, but that was about that. We bring them back with actually native multi-seed support that just works. So yeah, anyway, I can give you 1,000 reasons why systemd is more Unix than everything that came before it, in a way. But then again, I don't think that the question actually matters, right? Unix for us is an inspiration. It's probably the biggest inspiration we have. But ultimately, our goal is not to be the best Unix. Our goal is to write the best operating system. So we look actually everywhere. We look to Solaris. We look to Apple, like macOS. We look to Windows even. And if they have something that is nice, that people like, then we should actually think about adding something similar to our stuff if it's really good and if it's what people want. So yeah,